All right, let's finish up the notes dealing with how to classify triangles. So we're using our definitions to help us solve some of these values of x and the measures of the sides. So number 4 here says DEF is isosceles triangle. So I know it's isosceles, and then it tells me what two sides are equal. I've marked those two sides on my picture. Find x and the measure of each side. So I know these are the two equal ones, so I'm going to write an equation showing that those two are equal. So that's where I got this equation. Then I'm going to solve. Okay, so we did that first part. We found x. Now we're going to take that and plug it into each side. So 5 times 10 plus 17 is 67. 8 times 10 minus 13, 80 minus 13 is 67. And 10 plus 21 equals 31. Ooh, does that make sense? Well, sure it does. It's isosceles. We know these two sides are equal to each other, so their length would be the same. And this third side is not going to be the same. Okay, it could be bigger, it could be smaller. That part doesn't matter, but these would be the correct measurements of the sides. Okay, triangle STU is equilateral. So you'll notice I drew a triangle and I labeled it STU, and it's equilateral, so I marked all three sides equal to each other. You'll find what a big help it is to actually draw those out. This one happens to give us some lengths or some expressions for each side dealing with x here. So ST, this side right here, is going to be 1 less than twice x. So anytime you have a less than, it goes at the end. So we're going to do this first. Twice x is 2x. Less than is minus 1. Okay, so that's that side. SU, which is over here, is 37 less than, again, we're going to put that on the end, 5 times x. So 5x less than is minus 37. And the last one, TU down here, is 11 more than x. Okay, so more than and less than we usually put at the other end. Okay, so more than is going to be plus 11. Okay, so then it's really easy. Once you put those values in there, it's easy to see that which ones are equal and which ones are not. Now on an equilateral, they're all equal. So it says find x and the measure of each side, which we've done before. We can choose any of these. I'm going to choose the one that's the lower numbers. So 2x minus 1 should equal x plus 11. I could have also chosen this one to set equal, or I could have chosen this one to set equal. Either way, we'll get the same answer. So I'm going to subtract x here, so I have 1x. And then I'm going to add 1. So the value of x equals 12. Now they want me to go in and find the measure of each side. So let's start down here with the easy one. Okay, TU is going to be 12 plus 11, which is 23. ST is going to be 2 times 12 minus 1, which is 23. So what do you suppose SU is going to be? If it's equilateral, SU should come out to be 23. So let's check. 5 times 12 minus 37. So this is 60 minus 37 equals 23. Bingo, got them all. Number 8 down here, you'll also notice that I wrote out a picture. Drew a picture of a triangle that was isosceles, and you just draw a generic triangle. It's a little taller, and these two sides are usually the two equal ones. That's the easiest way. I chose M to be at the top just because both of them have M. So ML and MK are the two sides that are equal. I've marked them equal. I've taken this other information here of these three expressions and I put them on my picture. Now they want me to find x and measure of each side. So by doing all of this first row and putting it in picture form, now I can easily see which two do I need to use, because this one is not equal to the others. So I got to use these two. Set up my equation that they're going to be equal to each other. So subtract 7x. Then we're going to add 42. What do we get there? 42, that's 15. is going to be 27. I added 42, so it's going to be positive 27. Divide x equals 9. All right, so here we go. ML is going to be 10 times 9 minus 42. 90 minus 42 should give me 48. All right, let's see if the other one works out. MK. Let's see, 7 times 9 minus 15. So 63 minus 15 is 48. So that's good. Last one down here for KL. 4 times 9 minus 5, that's 36 minus 5 is 31. Ooh, just as like before. Is this okay? Yes, because it's isosceles. These two are equal. The third side, called the base, which we'll get into another lesson, that is not going to be the same as the two equal sides, so we are good. So, as always, if you have any questions at all, you let me know, and I'll be glad to help you out.